Hello everyone. So today we are going to start with a chapter multiple integral and we are continuing to lecture number 4. Topic is double integral. Now today we are going to consider the questions in which we are not provided with the definite limits. Instead of that we have been provided with curve. Now in this statement we have given the curve of ellipse. So from this one we'll calculate the value of limits of x as well as of y. Now, so coming to the question, so the given equation of ellipse is x square over a square plus y square over b square is equal to 1. Now, let it be equation number 1. So, we have to find the points of intersection on the x-axis and y-axis. So, on x-axis, we know that the value of y is 0, y is equal to 0. This implies x square upon a square plus 0 is equal to 1, or we can say x square is equal to a square, we can say x is equal to plus minus of a. And on y-axis, x is equal to 0. This implies 0 plus y square over b square is equal to 1. That means y square is equal to b square, or we can say y is equal to plus minus of b. So the graph of this type of curve will be someone like this one. Here we have x-axis, here we have x dash, y-axis, y dash, and this is the origin. So on x-axis we have the point a0, this is minus a0, 0b and 0 minus b. Now in the statement we have to find the area bounded by this ellipse in the first quadrant only. That means we have to work in this quadrant only. So for that one, the limit of x is fixed from this to this point. Let it be point A. This is O and this is B. Okay. Therefore, according to the question, required area is equal to area OAB. Now in this area OAB, the limits of x are varying from 0 to a, but whereas the limits of y, we have to take a variable limits. For that one, what I am going to start over here, I am taking a vertical strip PQ. So to consider limits of y as dependent, we consider a vertical strip PQ such that at P, what is the value of y? Since P is lying on the x-axis, so the value of y at x-axis is 0, and at Q, the value of y, now at Q, that means we are lying on the ellipse. So if we are lying on the ellipse, that means we have x square upon a square plus y square upon b square is equal to 1, or y square upon b square is equal to 1 minus of x square upon a square. I am taking LCM now. So it will be y square is equal to b square into a square minus of x square over a square, or we can say y is equal to plus minus b upon a into root of a square minus of x square. Since we are working the first quadrant, so that means we have to take the limit of y as positive only. So it will be b upon a into root of a square minus of x square. Therefore, the region or the surface R, which is being provided in the statement, R is the Cartesian coordinates x and y such that the limits of x varies from 0 to this point A, that is small a, and the value of y varies from 0 to root b upon a root of a square minus of x square. So that means the required integral I reduces to 0 to a, 0 to b upon a root of a square minus of x square into the function. Function was y dx dy. So y, now these were the limits of y, so y dy into d of x. So first of all we have to integrate with respect to y. So 0 to a, now integration of y will be y square by 2 within the limits 0 to b upon a root of a square minus of x square into dx, that is 1 by 2 outside. 0 to a, upper limit, it will be b square upon a square. Now root and square will be cancelled out, so it will be a square minus of x square minus lower limit is 0 into d of x. So it will be 1 by 2 b square upon a square to be taken on as common. 0 to a, now we have a square minus of x square into dx. So integral of this will be b square over 2a square. Now a square will be a square x and x square will be x cube by 3 within the limit 0 to a. So it will be b square upon 2a square. So it will be a square into this is a. So a square into a cube minus of again a cube by 3. This is the upper limit, minus 0 will be the lower limit. So it will be b square over 2a square. Now if I take LCM, so 3a square minus of a square. So 3a cube minus of a cube, it will be 2a cube by 3. So a square with this one cancel, 2 and 2 cancel out, and we are getting the result as 1 is left, a b square by 3. So this will be the answer for this question. Now coming to the similar question, in this one what we are having, statement is similar, but here we have to take the complete ellipse. So question is, evaluate double integral over the region R x plus y whole square dx dy over the area bounded by the ellipse x square upon a square plus y square upon b square is equal to 1. Okay, same thing. In first question which we have done earlier, it was ellipse bounded in first quadrant. Now here we have to take the complete ellipse. So starting with it, the given equation of ellipse is, the given equation of ellipse is x square upon a square plus y square upon b square is equal to 1. That is equation number 1. Now on x-axis we know that y is equal to 0. So this equation reduces to x square upon a square plus 0 is equal to 1, or we can say x is equal to plus minus of a. Similarly, on y-axis we know that x is equal to 0. That means 0 plus y square upon b square is equal to 1. That means y is equal to plus minus of b. Therefore, points on axis are, so first will be a0, then it will be minus a0, then it will be 0b, and then it will be 0 minus b. So I am first of all plotting the diagram for this one. This is a rough diagram. So this is the vertex A whose coordinates are a and 0. This have vertices as minus of I0. Now this is co-vertex and its coordinates are 0 to b, and this is 0 minus of b. This is our region O, A, B, C and D. So these are the coordinates of our ellipse. Now after this one, what we have to find the area bounded by the complete ellipse. That means all the 4 quadrants. Required area is equal to area of A, B, C, D. Now we have to check about the function also, whether the ellipse is symmetric about the function or not. Now the function which we have been provided, f of xy, that was x plus y whole square. So it will be x square plus y square plus 2 times x and y. Now x square is symmetric, y square is symmetric, but 2xy is unsymmetric. Okay, so that's why we have to take the area about the complete ellipse by taking limits from minus a to positive a and minus b to positive b. But one limit should be dependent and the other should be constant. So I am considering the limits of x as a constant, y should be varying. So for this one, consider a vertical strip PQ. Now this is our PQ, P and Q, such that at P, so the value of y, now we need to find the value of y from the equation of ellipse. X square upon a square plus y square upon b square is equal to 1. So that means y square upon b square is equal to 1 minus of x square upon a square, or we can say y square upon b square is equal to a square minus of x square upon a square, or y square is equal to b square upon a square into a square minus of x square, and y will be equal to plus minus b upon a root of a square minus of x square. Now negative means this value. Negative value will be over here and positive value will be treated over here. So at point P we have minus b upon a root of a square minus of x square, and at point Q y will be equal to b upon a into root of a square minus of x square. Therefore y varies from minus b upon a root of a square minus of x square to b upon a into root of a square minus of x square. These are the limits of y. Now x is varying from c to d, that is minus a to a, minus a to a. Therefore the region, it was region R. Therefore the region R is mentioned by xy such that x varies from minus a to positive of a, and y varies from minus b upon a root of a square minus of x square to b upon a root of a square minus of x square. So the integral will be minus a to a minus b upon a root of a square minus of x square to b upon a root of a square minus of x square, and the function is x square plus y square plus 2xy into dy and dx. Okay, now we have, let me start. Now we know that integral minus of a to positive of a f of x dx will be 2 times 0 to a if f of x dx, if f of x is even, and will be equal to 0 if f of x is odd or unsymmetric. Same rule will be applicable. Now this part is for even and this part is for odd. So it will be broken out in two parts, minus of a to a minus b to, now I'll take this part with the property 0 to b upon a root of a square minus of x square twice into the function x square plus y square, which was even, dy into dx plus 0 for this interval, okay, 2xy, because it is an odd. So it will be 2 times minus a to a, now integration with respect to y, so x square will be x square y and y square will be y cube by 3, within the limits 0 to b upon a root of a square minus of x square into dx. So now upper limit minus lower limit will be the case for this one. So it will be 2 times minus a to a, x square will remain as it is, y, that is b upon a into root of a square minus of x square plus 1 by 3 b cube over a cube into a square minus of x square raised to power 3 by 2. Now if I substitute the lower limit, the result will be 0 for this one into d of x. Now to solve this type of questions, what we have to do, since we have a square minus of x square root, so here we will use substitution method. So substituting this term, x is equal to a times sine theta such that dx will be equal to a, derivative of sine theta will be cos of theta into d theta. Now what about the limits? Now when I'll again arrange this one in the term of even and odd, so it will be multiplied by 2, limit will be from 0. Okay, so when x is equal to 0, so this implies 0 is equal to a sine theta, this implies theta will be equal to 0, and when x is equal to a, this implies a is equal to a sine theta, that means sine theta is equal to 1 or theta is equal to pi by 2. So the integration will be 4 times 0 to pi by 2 b upon a, x is a square sine square theta into root of a square minus of a square into sine square theta plus 1 by 3 into b cube over a cube into a square minus of a square sine square theta raised to power 3 by 2 and dx. Dx is what? That is a times cos of theta d theta. So it will be 4 times, now if I take 0 to pi by 2 b, now this a and 1a cancel out, so it will be ab, and a square if I take common, so it will be a because it is in root, so it will be a square b into sine square theta. Now 1 minus of sine square theta will be cos square theta and root of that will be cos of theta plus 1 by 3 b cube over a cube into, now if I take a square common, so root of that will be a and then cube, so it will be a cube into 1 minus of sine square theta raised to a 3 by 2, and after that we have a times cos theta d theta, expanding all the brackets now. So 4 times 0 to pi by 2, a square is this one and 1a is this one, so it will be a cube into b sine square theta, now cos into cos, so it will be cos square theta d theta plus, now this 4 by 3 a cube and a cube cancel out, we have only this a into b cube 0 to pi by 2, 1 minus sine square, that is cos square root will be cos and cube of this one will be cos cube, and then 1 4 cos raised to 4 theta d theta. Again I am utilizing the formula which we have done yesterday also, 0 to pi by 2 sine raised to p theta cos raised to power q theta d theta, that will be equal to p minus 1, p minus 3, p minus of 5 and so on till positive term over this part into q minus 1, q minus 3, q minus of 5 up to positive term, divide by p plus q minus of 2, p plus q minus of 4 up to so on till last positive term into, now if p and q both are even, so multiply by pi by 2, otherwise by 1. Now here it is 4 times 0 to pi by 2, limits are the same, a cube b into, now sine square that is even and this is also even, so p is 2 and q is 2, so 2 minus 1, then 2 minus of 3, we can't take it because it will be making a negative sign. Again q minus 1, so 2 minus of 1 over 2 plus 2 4 into 4 minus of 2, 2. Since both are even, so multiply by pi by 2 plus 4 by 3 a b cube. Now we have cos raised to 4 theta. So that means p is 0, q is 4. So 4 minus 1, 4 minus of 3 over 4, 4 minus of 2, that will be 2, multiplied by pi by 2. So it reduces to 4a cube b into 1 into 1 into pi by 2 over 4 into 2 plus 4 by 3 ab cube into 3 into 1 over 4 into 2 into pi by 2. Now this 3 and 3 cancel, 4 and 4 cancel out, this 4 and 4 cancel out. So what we have? Pi a cube b over 2 2s are 4 plus pi a b cube over 2 2s are 4. So that means pi by 4 is common and we have a cube b and ab cube. So that means I can take ab common. So pi a and b common, divided by 4 is also common. So we are left with a square plus b square. So the final answer for this question will be a into b, a square plus b square into pi by 4. That is the result of this question. I hope both the cases are clear to you. In the first case, we have taken the ellipse, but in the first quadrant only. And in the second question, we have considered the whole of the ellipse. That's it. Thank you.